quick explanation on the logarithm question in your A-Maths paper. Right, so what I see here maybe is probably a wrong application on the change of base. Okay, so maybe I want to explain conceptually how the change of base actually work. Like, we know how to apply the formula, right? But why? Why does it work? Why should I trust the formula? Right? So let's look at an example over here where we're going to use a concrete example, right? Something that's easy to imagine. Let's think of log base 10, which is your common log. We're going to take 1 million, 10 to the power 6. Okay, and in many ways we kind of know the answer to this. One way is to use the literal meaning of the log function. When we take the log function, what we're trying to say is 10, the base, to what power will give me this thing over here, 10 to the power 6. So you ask yourself, 10 to what power will give me 10 to the power 6? And the answer is 6. Okay, so I'm going to call this the left hand side. The left hand side, the answer is 6. Okay, and then on the right hand side, we're going to use the change of base formula. Okay, and then we're going to try and figure out why does it work. Okay, so to recall the formula, I think everyone knows. Yeah, say I want to change to base 1000. Let's just say if I want to change to base 1000, then you just write log base 1000 for your numerator and denominator. Okay, in the numerator, you write what was on top previously, 10 to the power 6, and at the bottom, you write the previous base, which is 10. Okay, so let's look at this bit by bit. Let's try and figure out the answer. First, the numerator. The numerator is asking 1000 to what power gives me 10 to the 6. Okay, so I think it helps if you think of 1000 as 10 to the 3. So again, 1000 to what power will give me 10 to the 6. And then you can see, oh, it's 2. So the numerator has an answer of 2. Then let's look at the denominator. Yeah, in the denominator, you're asking 1000 to what power gives me 10. So again, 1000 to what power gives me 10 to the power 1. 10 is 10 to the power 1, right? So you can see the answer is 1/3. And then you have 2 divided by 1/3. You change flip, that's 2 times 3. I won't write that down. The answer is 6. So yeah, the formula works, but why, right? What is going on underneath the algebra? How can we visualize something concrete from here? Okay, so first of all, let me introduce you to this function over here. What you can think of this as, okay? The log base 10, the common log function, is kind of like a zero counter, right? It counts how many zeros in your tens, 100,000, millions, billions, right? So for example, if I have log base 10 to a billion, then you know the answer is 9, yeah, which happens to be the number of zeros 1 billion has. Or in this example, we did a million, you get 6 because that's how many zeros 1 million has. We're counting the number of zeros that this number has. Okay, so if you look at the right hand side, what's actually happening? What's actually happening is this. Over here, this is very similar. Okay, this is also a zero counter, but it doesn't count individual zeros. It counts in groups of 3. Yes, log base 1000 is asking how many thousands, right, are there in 10 to the power 6? How many thousands do I have in 10 to the power 6? So you can imagine it this way. Instead of having counting individual zeros, we count it in terms of 2 groups of 3 zeros. Yeah. So that's what the numerator gives you. It tells you there are 2 groups of 3 zeros. Okay. Then what about the denominator? Okay, the denominator is kind of asking like, okay, then in your 2 groups of 3 0, how many zeros are there in each group? And the answer is 3. Although it comes out as 1/3, but you'll see later when you do keep change flip, you'll flip back to 3. Okay, so actually that is what's happening when you do change of base. Instead of counting your 6 individual zeros, you count it another way. You count it as 2 times 3. Okay, that's the change of base, why it works. Another example would be if we did the same thing, log base 10, 10 to the 6. This time instead of changing to log base 1000, I'll do log base 100. So log base 100, 10 to the 6, log base 100, 10. Okay, so in the same way, we can figure this out ourselves. We can say that, oh, 100 to what power, oops, is going to be 10 to the 6. And the answer is 3. Okay, then you can think of this as if I count in terms of 2 zeros at a time, because 100 is 2 zeros, right? How many groups of 2 zeros are there in 1 million? And the answer is there are 3 groups. There are 3 groups. And then you can probably guess what is the fraction over here. This is going to be half. Why? Because in each group, there are going to be 2 zeros. Okay, but let's just do this very quickly. 10 to the power 2 raised to what power will give me 10 to the power 1, and the answer is half. Okay, so this is what is actually going on when you do a change of base. Yeah, instead of counting individually, you are breaking it down into groups, and then in each group, how many are there? Sort of this way. Yeah, so that is why it works. And then if you look at this question, yeah,